So
Looks really good.
so it's looking pretty good. I'm gonna hit enter room just to see what it's like.
It's actually running fairly good, but
Running
we
pretty
are
pretty well.
here on a,
We're on a pretty monster
yeah, pretty monster.
laptop here.
Yeah,
This laptop has
it's like a
a
2080, right? Yeah,
2080
like a,
RTX
yeah, all the
NVIDIA card in it,
all the
but
things.
and so it's not capped. It's running at like 70 some frames per second. But if you were on a lower end machine and definitely one without an integrated graphics card, you'd be in a lot of trouble.
Yeah. So let's take a peek and see what we're rendering right now. So the easiest way to do this is in the bottom right corner, there's a little FPS meter in hubs. And if you click that,
It's
yeah, it's pretty
gray and
faint,
down in the
but we,
tiny corner there, so it
yeah,
might be hard to see. But if you click on it, it'll open up a web
yeah.
uh, monitor kind of thing
So what's
here.
that saying when they're there? So it's saying um, at the top you have your frame rate. We're doing pretty well there. Um, it's comfortably sitting
Probably
at
looks really
70
good when I'm
something.
not looking at that statue. It might go up a
Yeah,
bit.
no, it's going up a little bit, but yeah. And we have our batching stuff. We can go into that later. And then we have the objects in our scene. So we have 25 textures, 19 programs, and 15 geometries
How
right
many
now.
triangles are we looking at here? Because
We're
my
looking at
eyes
a
are
lot.
not good enough to see that for me.
So that's actually saying 300,000.
Whoa,
Yeah, and 10 draw calls, that's pretty okay. But yeah, kind of a lot.
kind of a lot. Just to give a sense of it, um, people ask a lot about the difference between running something in VR on a desktop platform versus running
Hmm.
on like a standalone headset like a Quest or on their mobile phone or something like that. The difference in performance between the two, obviously it varies with a high-end machine versus a very low-end phone or something like that. But in general, the guidelines tend to be that the desktop can run about 10 times as much stuff
Yeah,
as a mobile headset.
it's about 10 times faster than the mobile headset.
Yeah.
So
So we're looking at, if a scene runs pretty well, let's say at you know, 10,000 triangles on a mobile device, the PC can handle like 100,000, like no problem.
yeah, they usually say about, so for poly count, they're looking at around 200,000 as your upper limit. We can actually look that up. But Oculus has a really great documentation on uh, what the limits are for each device. And I think if I remember correctly, it's about 200,000 polys on like the desktop platform,
Yeah,
and around like 200 draw calls, and it's about half of that uh, on the Quest.
right.
So we're way above that. And with hubs, like what we're really trying to do is we're trying to create content that looks good and runs well on all platforms. We support every VR headset pretty much out there. We support phones. We support like low-end laptops. So we really want this thing to run well on all those different platforms. Um, so I think we're going to have to optimize that asset. It
Yeah,
looks really good in the
because it
scene.
looks great on desktop and especially on this computer, but 300,000 triangles,
Yep.
even for a hero asset like this, is a little high,
Yep.
and or it's actually a lot high,
And then when
considering
you,
that it's way bigger than probably the rest of this scene.
right,
Um,
when you factor in all the avatars as well, then that's going to play into that as well. So maybe this is a good time to stop and just talk about what makes an asset expensive. So when you're looking at this panel, um, you can see the number of polys and the number of calls it says under that. That's the number of draw calls. So when
what is
the
a draw call, Robert?
yeah, so when the graphics
I
card
use the
is
term all the time, and I
yeah,
think sometimes I pretend I know what it means more than I actually do. So
so when the graphics card is doing all the work of drawing your scene, you can imagine every single individual material of your scene. So that these walls, maybe the floor is a separate draw call. The background out there, the skybox, which you can't see in this thing, but it's still drawing it. still doing a separate draw call for that. Notice it's going up and down depending on where you're looking at in the scene.
So it just dropped down to what, 8 now? Because it's no longer
Right.
in view
Yeah, so it's
of
not
the
so
camera.
we can kind of think of the scene behind us as two draw calls probably. And it's going up and down because of a thing called frustum culling, which is if you imagine like maybe like a cone on a dog. You know
What
the
can the dog see out
yeah,
of
what
this
can the
cone?
dog see out of the cone? And that's kind of
I've never
like
heard anyone use that
yeah.
analogy, but it's a good one.
So everything within that frustum is what is currently being rendered. Um,
So that includes avatars, and if you're talking about the web as well, you'll notice like we have UI on the screen. Those things count because right, it has to draw not just the 3D things, but
yeah,
also the 2D things, including this little panel that's popped up right now,
that
probably.
that panel will be
Do they add
outside.
that?
That's in like the browser level.
Okay, so we don't worry about that.
Yeah. So, anyways, so it looks like we're, we're doing pretty well on draw calls here. So the GPU is only gonna draw uh, two things for that room and for the statue, but the rest of the scene is taking up around 8. Um, and each one of these things is going to be drawn in a separate little pass of the scene. So it's going to go and it's going to draw that statue, and then it's going to go and draw the scene around it. And yeah, it just kind of builds these layers up one after the other.
And we're gonna
Um,
we're gonna wait and talk about lighting, right?
yeah,
Lighting actually contributes quite a bit to
hmm
those
to
things
the
we're
draw
talking
calls.
about,
Yeah,
but we'll get into that in more detail in a bit.
and so you're going to have a draw call per unique material in your environment. So materials are a big thing that contributes to
I'm gonna throw a
the
duck into the scene. We'll watch the draw calls go up from
yeah.
10 to 11.
There you
Now we
go.
have another thing.
Yeah, because it's got a unique material on that thing. So you want to avoid that. That's probably the largest contributor to performance. In fact, even more so than poly count. But there is a cap on the amount of polygons that you want to render. Um, and then there's polygon count. So when you're rendering the scene, it has to go and it has to render all of these different triangles that make up the scene, and it then needs to go and fill in those triangles with all these pixels. Um, and so the more triangles that you have in the scene, the more expensive it is. It's not rendering all of them at once, which if it's blocking part of the scene, then it's not filling those triangles in.
Right.
But in this case, we're looking at this whole statue, and
And
it's
also
going
just
to be
for a
somewhat
frame of
expensive.
reference, we talked about how this statue is a lot of triangles. Um, what did we say it was? Like, well, if we go to Sketchfab, we can find out.
Yeah.
It will tell you right here. This statue of Achilles alone is 282.6 thousand triangles,
hmm
which, just to give a little bit of understanding, in this scene, I don't know how many triangles this tower is, but this background, this crater itself, which is pretty big, it's not super high detailed or anything, but it this whole background only has about 4,500 triangles.
Right.
It's like 4,000 triangles versus 282,000. So
Yep.
we're spending a lot of our budget right now on this guy, which, depending on what you're doing, could be cool. But if you're on mobile, we're definitely going to have a bad time. So um, let's take a little longer look at it in Sketchfab and see what we're dealing with here. Now, there's a couple ways once you are looking at an asset in Sketchfab that you can tell um, what's making it expensive, or how is it made.
Just kind of all the stat
So
breakdown
we've
here.
got triangles here, we've got vertices, and if you click on more model information, you can find out a little bit about the format it was created in. This was made
Yeah.
uh, as
OBJ,
an OBJ, which okay.
which is usually when you're doing photogrammetry, whatever tool you're using is going to spit that out.
The download size of this is what's interesting to me. We already know the
Right.
triangles and stuff, but the download size is 34 megs.
Right. And
So just like opening that model up in Spoke, I mean, it had to download 34 megs worth of stuff, which is
Right.
the same in hubs. So if you're on a mobile device, you're on a cellular signal, and
Yeah.
you're not even on Wi-Fi, like not going to be fast to load.
Right. And then there we see it has two materials. So if I were to guess, I would guess that the base of that thing, the marble underneath it, is probably one, and then the statue is probably another.
They look pretty different, yeah. And
Yeah.
then you can also inside this info panel click on See All Files, and it will actually show you,
Oof.
wow. So the texture resolution on these textures that came in ended up being like 8,000 by 8,000. I
Yeah.
don't that seems a little crazy to me.
Yeah.
They are JPEGs. They are 5 megs, 6 megs in size
It's not
each.
too bad for how big that image is, but that seems to be more resolution than we probably want to use for our
Yeah, or really need
scene.
for that
Yeah.
matter. You can also see, yeah, it's two materials. There's the thing has vertex colors. There's some things about this we can talk about later, but it'll tell you if the thing has animation or it's rigged with a skeleton and all that kind of stuff.
Yeah.
So good to know. We don't necessarily care about all that information right now, but um, the cool thing about Sketchfab, if I can plug those guys a little bit, is that not only do they provide a place for you to store and display models, but they automatically will, after you upload a file on their cloud or whatever, they will automatically convert that to a GLTF file, which is exactly what we need.
Hmm.
So it's pretty great, even though the person uploaded this model as an OBJ. When we go to download it with the little download link, we actually have a choice. We can take that original format, or we can take their auto converted GLTF file,
Right.
which is great. We've already done that before this in cooking show style. We already have that one in the oven, so we're gonna bring that into Blender and take a look at it.
Yep.
I think we're ready to go there.
Let's do that.
So let's switch over. I'm gonna do my